Hey ANPers, this is Dr. Jones checking in. This is ANP 1, Lecture Test 3, Video 7 on page 8. All right, so we're still in Chapter 6, talking about bones. Let's talk about appositional growth. In appositional growth, the osteoblasts in the periosteum add layers of bone superficially, while osteoclasts remove bone, enlarging the marrow cavity. So this allows the bone to grow larger in diameter. So if you cut the bone here, bone, and it's like a donut, right? Because there's bone and then a hollow marrow cavity. So in appositional growth, osteoblasts add layers of bone on the outside of the bone. The same time, okay, so I figured out how to do this. I'm going to do this with a white pen, and when I draw over, wait, I have to draw this whole thing in blue first, aren't I? Okay, blue donut, blue donut, blue donut. Hey, if I can draw it, all y'all can draw it. I maintain that. All right. That looks like a blue donut. Just, you know, suspend your disbelief and all. Okay, so now, appositional growth. The osteoblasts add bone superficially. At the same time, white, osteoclasts break down the bone in the center. So the bone, again, like the epiphyseal plates, stays about the same width. And keeps growing. We'll do one more round. It gets bigger around. What, you know what I mean. And then it gets erased. And the marrow cavity gets bigger because the what cells destroy the bone from the inside? Osteoclasts. And cells build the bone from the outside? The osteoblasts. And as a review, but not in white because that won't show, what structure allows the bone to grow in length? The epiphyseal plates. And where are they located? The metaphyses. What's in the epiphysis? Spongy bone, not the epiphyseal plates. Excellent. So now let's talk about intramembranous ossification. That was endochondral ossification. Intramembranous ossification produces flat dermal bones, such as the mandible, clavicle, and skull. And that's kind of all we need to say about that. Next, the blood and nerve supply to the bone. In order for the bones to grow and be maintained, they need a blood supply, a steady blood supply. The periosteum also contains blood vessels, lymph vessels, and sensory nerves. The central canal and perforating canals contain blood vessels and nerves. So there are nerves we just didn't have them in the picture, but there are nerves there in both central canals and perforating canals. And a neurovascular bundle is a bundle of nerves and vessels. Neuro means nerves, vas means vessel, neurovascular, blood vessels, and nerves. It's just like if you build a new house, you put kind of all the piping together in one to do because it's easier. Same with the body. The pipes, the nerves, the arteries, the veins, the lymph vessels all tend to run together. So neurovascular bundle. Like the blood vessels in your fingers go up the sides, which is also where the nerves are. So if you get stitches, wait, which one has the stitches? There you go. So if you get stitches, I don't know if you can still see that. No, you can't even see it anymore. Right there. So if you get stitches in your fingers, they're going to inject the nerve block at the base of the finger on the sides because that's where the nerves are, on the side. It's just like if you are trying to get blood, a drop of blood to test blood glucose or some such, you don't go in the middle of the pad because that's not where the blood vessel is. You go off to the side. And if you have to squeeze too much, then you kind of change the consistency of the blood you're going to get because you're getting interstitial fluid squished out with it. So you want to go in the side of the finger because that's where the blood vessels are. And then hopefully you shouldn't have to squeeze so much because that sucks. Okay. All right, and what is bone remodeling? It's when you recycle and renew the bone matrix. What is the turnover rate in bone in a young adult? 1/5 of the skeleton is replaced in 1 year. Is the bone remodeled all at the same rate? No, of course not. The femur head is remodeled 2 or 3 times a year, whereas the shaft remains largely unchanged over time. Some heavy metals, and explain how they can interact with the skeletal system. So, lead, strontium, cobalt, radioactive uranium, and radioactive plutonium. So radioactive compounds are especially damaged because they are released slowly over time as those bones are remodeled. So it's like they're stored in the bone matrix. They're stored in the bone matrix. Like anything that comes along. It's mostly calcium, but there's all kinds of crud that gets stored into the bone matrix. And as the bone remodels slowly over time, you have this steady release of radioactive compounds into the bloodstream to float around the body and do all kinds of damage. And so radioactive exposure is a lifelong problem, if it doesn't kill you all at once, is a lifelong problem because that radiation gets stored in your bones and then continues. So that sucks. Okay. Oh, well, that was page 8. That was page 8. So we'll just have a super duper short video. So this has been A&P 1, Lecture Test 3, Video 7 on page 8. Thank you as always for tuning in. Dr. J out.